Okay, so let's look at an example now of how we would actually calculate the determinant of a larger matrix. Okay, and this is still page 88 that we're looking at here. Example 3. Okay, we've got a 3 by 3 matrix that we'd like to take the determinant of. And I'm going to illustrate to you a way that we can use those formulas that we talked about at the top of this page to do that. Okay, and the way I like to start a problem like this is making what's known as a sign matrix. Okay, for our 3 by 3, and a sign matrix always starts with a plus sign in the upper left hand corner and just alternates. Okay, so we're just going to alternate our way through across our rows and down our columns, and this is what I'm going to call the sign matrix for -1 to the I plus j. You might recognize that as appearing in some of our determinant formulas earlier. Okay, what does that mean? Well, basically what it's saying is, if we want to know where did this plus sign in the upper left-hand corner come from, we would just ask ourselves, what row and column are we in? Well, we're in the first row in the first column there. So going over here to -1 to the I plus j, it's like plugging 1 and 1 in for I and j, because those are our rows and columns. -1 to the 1 plus 1 is -1 squared, which is 1. That's positive, and hence the plus sign that we have there. Okay, you can get any sign in this sign matrix in the same way. If you jump one entry to the right, for example, now we're in the first row in the second column. So I is 1 and j is 2, and we're taking -1 cubed, which is now negative. Okay, and so we get a negative sign there. And every single sign that you see in this matrix is generated by taking that -1 to the I plus j and just filling in the row and the column. Okay, let's get rid of those circles that we made there. Okay, and we are ready to use that sign matrix to help us calculate this determinant. Okay, so I'm going to just recopy the matrix. Okay, and there are 3 pieces here, the same 3 pieces that we talked about earlier. Okay, so we are going to choose to expand along the first row. We could actually choose any row or any column. Okay, and the first thing that we're going to do is to just write down those 3 entries in order. Okay, there's a 1, there's a 2, and there's a -3. Next thing we're going to do is to go up to our sign matrix, okay, and ask ourselves, what does the first row of that sign matrix look like? Plus, minus, plus. Those signs are going to go in front of the 3 numbers that we wrote down. Okay, and then finally, we are going to multiply by the tilde matrices that are appropriate to each one. Okay, and this part is a little bit more complicated, so let's get ourselves a different color. So starting with the 1 that we see here, okay, we're going to go back over to our matrix, and we're going to cross out the row and the column that 1 is in. And then we're going to write down the determinant of the 2 by 2 matrix that's left. Okay, in this case, it's going to look like 1, 3, 0, 1. Okay. So we've completed the first term. Okay, so let's erase so that we're ready to do the next one. Okay, and we come to -2. We're going to do the same thing. Find that 2. Okay, that was sitting here. We're going to cross out that row and column. Okay, and the 2 by 2 matrix that's left this time looks like -1, 2, 3, and 1. Okay, and we've completed the second term then. All right, so let's erase, and then we come to the last entry. Okay, sorry for continuing to change colors on you, but I think it helps us to see this a little bit better. So we're looking at the -3 entry. We're going to cross out the row and the column there. Okay, and write down the 2 by 2 matrix that's left. Okay, determinant of negative 1, 1, 2, 0. Okay, so basically what we've done is we're calculating this determinant by expanding it into three 2x2 determinants, which we already know how to calculate. All right, so let's see if we can complete the arithmetic here now. So we've got a 1, and then the determinant of this 2x2 is going to look like 1 times 1 minus 3 times 0. Okay, and then moving on to the second one, we've got a minus 1 times 1 minus a 3 times 2, and then finally plus a negative 3 times negative 1 times 0 minus 1 times 2. And then just a matter of doing the arithmetic and seeing what we get. So there we're going to get 1 times 1 minus 2. Negative 1 minus 6 is a negative 7, it looks like. Okay, and then finally a negative 2 there. Okay, and you can do the arithmetic and confirm this. What we're going to end up with here is 21 for our determinant. Okay, and that's our answer. We're done. Okay, but I want to illustrate just the fact that there was nothing special about that first row that we chose. We could have chosen any row or column that we wanted to. Okay, and so I'd like to repeat this calculation. Okay, let's get rid of some of the work that we already did. Okay, but this time I would like to choose the second column of the matrix, and you might look at that and notice that there's a 0 in the second column. 0 is a nice number, and so having a 0 is an advantage, as we're going to see. All right, so we'll start this whole calculation over again. I'm just going to recopy the matrix again. All right, we are going to choose the second column and just repeat this calculation, just confirm that we get the same answer. All right, so going back to our sign matrix at the top of the page here, I'm going to first get rid of the row that we circled. Okay, recopy it in. Okay, and just highlight the second column since that's what we're going to expand along this time. Okay, and if we repeat the same steps that we did before, we're going to start by writing down the 2, 1, and the 0. Okay, those are just the entries in the second column. Okay, and then we're going to put the signs in front of those numbers that appear up here at the top. Whoops, sorry. In our sign matrix. Okay, from top to bottom, minus, plus, minus. All right, and then we need the 2x2 tilde matrices, okay, that go with those three entries. All right, I'm going to scroll up just a little bit here. Okay, so starting with the 2, we want to cross out the row and the column that 2 is in. Okay, and write down the 2x2 matrix that results, negative 1, 3, 2, and 1. Okay, so we're done with the first term. Okay, then we'll move on to the next one. Okay, so let's get rid of what we wrote there. All right, and now we're moving on to the 1, which was the entry that's right in the middle of our matrix. We want to cross out the row and the column that's in. Okay, and write down the 2x2 that's remaining. Okay, you can see what it looks like. 1, negative 3, 2, and 1. Okay, and then finally, moving over to the 0. But if you think about it, it doesn't really matter what comes after the 0 because 0 times anything is 0 anyway. Okay, so I'm just going to write kind of a blank determinant because we don't care what's in there. That's going to go to 0 anyway. All right, so continuing with the calculation, as before, we've broken it down into 2x2 matrices, which we know how to find determinants of. So we're going to get negative 2 times. Negative 1 times 1 is negative 1, minus 3 times 2 is 6. Okay, plus 1 times 1 is 1, minus a negative 6. Okay, continue with the arithmetic here. And notice that we get exactly the same thing that we did before. 21. Okay, so as you look back over this example, you might ask yourself, which was the better way to do this? Okay, expanding along the first row like we did up here. Sorry. Or expanding along the second column like we did here. Okay, I think you'll agree the second column is a better choice because of the fact that we had a 0. Decrease the number of calculations that we have to do. Okay, and when you calculate determinants on your own, you can keep